So we're going over P6, which is factoring. Some factoring tips. Look for the greatest common factor in order to simplify the expressions. Look for special products that can be x squares, x cubes, that maybe you can take out. There's trinomials. Is A equal 1 or is A greater than 1? That makes a difference. Are there 4 terms? Can I group? So it's always good to look at those things before you start in order to try and make yourself, give yourself an easier problem. So I'm going to start by reading what's here and going on from there. So P6, you start, you have common factors, factoring trinomials, special factoring formulas, factor an expression completely, and factoring by grouping of terms. That's kind of how you always want to try and take this. It will make it easier if you have a order of approach instead of just going off of a random, looking at a problem, seeing how it goes. So we use to distribute property to expand algebraic expressions. We sometimes need to reverse this process, again using the distributive property by factoring an expression as a product of simpler ones. So for example, you can write x squared minus 4 as x minus 2x plus 2, and that will be factoring if we're going from the x squared to the parentheses. But if we're going from the parentheses to the x squared minus 4, then that would be considered expanding. So we say that x minus 2 and x plus 2 are factors of x squared minus 4. That is, when you FOIL them, you get x squared minus 4 when simplifying. So the easiest type of factoring occurs when the terms have common factors. So common factors is the easiest type of factoring that occurs when the terms have common factors. That is when you can take out the greatest common factor, or you can start simplifying in order to get the term and the equation or the expression to become simpler. So example 1, factoring out common factors. So for each expression we have AB, and I wrote down AC. So we have 3x squared minus 6x. Now, the greatest common factor. The greatest common factor here is 3x. Why is it 3x? Because I can take out a 3x from the top, from a 3x squared, and I'm left with x. And I can take out a 3x from the 6x, and I'm left with 2. So you want to divide the greatest common factor, and then whatever you divide by goes in front of the new equation. How do you know if this is correct? If you were to multiply it back in, you should get the original equation. That is the key word, original equation. Now, let's look at B. What are the terms that I can take out? Well, all of the terms are a factor of 2, so I can take out a 2. Do all the terms have x's? Yes, all the terms have x's. The biggest x I can take out is 1, because this x right here is just 1. And then all of the terms have y's. Yes, they do. Now, the biggest amount of y's I can take out is 2, so that's why it's going to be square, because the smallest y in all of the terms is the x squared that we have in that first term. Now, when I do that, again, I'm going to take out what I divided by first. That goes in the front. Now I can divide, well, 8x to the 4th y squared divided by 2x y squared. 8 divided by 2 is 4. Now I can subtract the exponents of the x's because of the exponents rule, so it's going to become x to the 3rd. I can do the same thing for the y. It becomes y to the 0, and again, anything to the 0 power is 1, so we're just going to leave that as 4x cubed. Now plus 6 divided by 2 is 3, x cubed, and then divided by x is just x squared. Again, I can just subtract the exponents, and then we have y cubed and y squared. Subtract the exponents, it's y to the 1st power, or just y. And then lastly, I have 2x y to the 4th divided by 2x y squared. 2 divided by 2 is 1. I'm not going to write it. X divided by x is just 1. I'm not going to write it. And then we have y to the 4th divided by y squared. Again, 4 minus 2, we get y squared. And that's how you get the inside of that parentheses. Now for this problem, C, negative 15y to the 4th plus 5y cubed minus 10y squared. I'm going to go ahead and get the greatest common factor. It's 5y squared. Now, I want the very first term to be positive, so I'm just going to go ahead and make it negative so it flips over later. That's something I recommend you doing. You always want that first term to be positive. It'll make it easier in the long run. But if you didn't and you end up with a negative number, that's okay too. So we have 5y squared. And then the inside is going to be 3y squared minus y plus 2. So I'm going to write down what we have been doing here. So we are dividing out, just so you guys have it, the greatest common factor. So that means that the greatest common factor goes out in front of the parentheses. All right, so example 2, factoring out a common factor. So we have factors 2x plus 4, x minus 3, minus 5, and then x minus 3. Notice how we have right here an x minus 3 and an x minus 3. If you think about it, we've been taking out a greatest common factor of actual terms, not necessarily just an equation. So we were taking out numbers or letters. But because this is in a parenthesis, we can think of this as a random number, and we can take it out as we have been doing the entire time. So for example, I can write the remainder 2x plus 4 minus 5, and then outside I can say, well, I can multiply all of that by x minus 3. It's something that is shared for both of them, so we are able to take it out. Now, in order to simplify, you're going to have to combine the 2x plus 4 minus the 5, so I'm just going to go ahead and write it in. 2x plus 4 minus 5, all of that times x minus 3. I can combine the 4 and the 5, so I get 2x minus 1, and then x minus 3. So just by factoring out that parentheses, you're able to get the answer a lot quicker. You don't have to distribute everything to then take it out at the end. If you're able to see that you have the same parentheses on both terms, you can take out the entire parentheses as if it were just a letter or just a number. So factoring trinomials. To factor a trinomial of the x squared plus bx plus c, we know that x plus r, parentheses, x plus x equals x squared plus r plus s, x plus rs. Now this is factoring as you guys have done over the whole high school year. So you have a trinomial, you factor it out, you get the factors from the c, and they have to add up to the b. So we need to choose numbers for r and s so that r plus s equals b and r times s equals c. So what I just said. For example, factoring x squared plus bx plus c by trial and error. There's multiple ways of doing it. You guys did not get taught trial and error. You guys got taught to multiply these two, right? And get the factors of those, and at the very end divide by a. Now in this case, we don't have an a for any of these terms, so we're gonna focus on how to solve this. So the factors of 48, you'll notice I always do my factors on the side. You don't have to. They're 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Now, you don't have to write all of the factors. In this case, I needed to because 6 and 8 are the only two that can possibly add up to a -2 that will multiply you to a -48. If you find it before you get to the end, by all means, go right ahead and do so. You don't have to write all the factors. So when I do that, again, I can make that 8 negative, and we'll get that -2. And -8 times 6, it is actually -48. So we are on the right track. So it would be x. Oops, I clicked the wrong button. So it's x and 6 and x and 8. Now we know it's going to be -8 and +6 because -8 times 6 is -48. So multiply to your c. And -8 plus 6 is going to add up to -2. So we're going to do the factors of 30. The factors of 30 are, remember, we wanted to add to -1. So it's 1 and 30, 2 and 15, 3 and 10, 5 and 6. Now 5 and 6 are the only ones I can add up to -1, making the 6 negative and the 5 positive. Now this will also work because -6 times 5 is -30, which is exactly what we're looking for. So we have y plus 5, y minus 6. Again, if you were to have written it the other way, y minus 6 times y plus 5, that is okay too. The order here doesn't really matter. I'm just going from the order of the factors in which I wrote them down in. It doesn't matter. If you know that 5 times 6 equals 30, and you know the difference is of 1, you don't have to write out all the factors. I'm just doing it to show you guys all the steps. Now I'm going to do the factors of 30 for 3. I want them to add to 17. So we have 1 and 30, 2 and 15. I could keep going and do 3 and 10. But 15 and 2, if I add them, they're already 17. So I'm just going to stop here. They're both positive, so I can do 15 plus 2 positive. And then 15 times 2 positive gives me positive 30. So since it works for both signs, I can just go ahead and write x plus 2 and x plus 15. It doesn't matter, as you saw in number 2, if you have an x, a y, a z, a w. The letter doesn't matter. It's always the same procedure. So for number 4, we got to do the factors of 27. Well, the factors of 27 are 1 and 27. 2 is not going to work. It's going to be 3 and 9. Now, 3 and 9, if I add 1 and subtract the other, I do get positive 6. So if I do plus 9 minus 6, I get positive 6. And if I do 9 times -6, I get -27. So I can stop there. I don't have to keep going. So it's going to be x minus 3 and then x plus 9. Again, this will be your answer. Like if you wrote x plus 9, x minus 3, that's fine as well. So I'm going to go for the factors of 50 that add up to -23. So let's just take it one step at a time. It's 1 and 50, 2 and 25. Now I'm not going to keep going, as I know if I do -25 and +2, I'm going to get -23. So I'm going to go ahead and try that one out. We know we multiply to 50 because those are the factors we're taking out. So -25 times 2 does give us 50. So it's going to be x plus 2, x minus 25. So for example 4, factoring ax squared plus bx plus c by trial and error, we got to factor 6x squared plus 7x minus 5. Now, instead of doing that one, let's do the 5 examples we have written down. I'm going to write down the steps for you guys and for myself. So, the first step, I'm going to write 1 instead of little star. 1 is to multiply A and C. Multiply A and C. 2 would be to find the factors that add up to B. Three would be to replace B with those factors with the appropriate variable. And then the last step would be to factor by grouping. So I'm writing the steps down so you guys have a reminder, myself included. So for the first step, number 1, we have to, first step, multiply A and C. This is your A, this is your C. So 3 times 5 is 15. It's -15. So the factors of -15 are 1 and 15, 3 and 5. Now, One of them has to be positive and one of them has to be negative. I'm only going to worry about that when I can figure out which ones add up to -2. In this case, it's the 3 and the 5. The 5 is negative, the 3 is positive. Now they multiply both to -15, and they add up to -2. All right, after we find the factors, we're going to write 3x plus 3, and then 3x minus 5. Again, the 3 and the 5 doesn't matter where you put it since we have the same a. Because we have a square, we're going to put a 1x over here and 1x over there. So I can actually now simplify the terms. I can divide this first one by the greatest common factor, which is 3. So we're left with x plus 3. Sorry, not x plus 3, x plus 1. And then this one I can't simplify anymore, so we're left with 3x minus 5. So this would be the final answer. So for number 2, we're going to do, well, 9 times 2 is 18, so we're looking for the factors of -18, as one is positive and one is negative. So it's going to be 1 and 18, 2 and 9, 3 and 6. Now I'm pretty sure it's going to be 3 and 6 because those are the ones that could add up to +3. If we make that -3 plus 6, they add up to +3. -3 times 6 gives us -18, which is exactly what we're looking for. So we have 2y. Again, it doesn't matter where you put the variables. I'm just going to write -3 plus 6. There's nothing I can do to that first parentheses to simplify it. So right now, the first parenthesis stays the same. Now that second parenthesis I can divide by 2 because 2 is divisible by 2 and 6 is divisible by 2. So we're left with y plus 3. This being your final answer. So now we're doing 5 times 12. 5 times 12 is 60. So the factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15. All right, 4 and 15 are the only ones that add up to 19. That will multiply to 60. So I'm going to go ahead and write 5x plus 4, 5x plus 15. Again, in this case, they're both positive, so they're both going to be positive in the parentheses. 5x plus 4, I cannot simplify, so it's going to stay as 5x plus 4. And the other one I can divide by 5, so 5x divided by 5 is x. 15 divided by 5 is 3. So we're left with 5x plus 4 and then x plus 3. For number 4, we're going to look for the factors of 10. So we have 1 and 10. We could keep going, but those already add up to 11. And 10 is positive, so we can just go ahead and do, well, 2y plus 1, 2y plus 10. I can simplify that second parenthesis by 2 to get 2y plus 1, and then y plus 5 as our answer. So here we're looking for the factors of 4 that add up to 5. 1 and 4, they're going to add up to 5. There's no reason to keep going. So we're going to get 2x plus 1, 2x plus 4. I cannot simplify the first parentheses. The 2x plus 1, I can simplify this one by 2, so I get x plus 2. So for A, we're looking for the factors of 3 that add up to 2. Again, it's going to be -3, so one's going to be positive and one's going to be negative. So the factors are 1 and 3. That works perfectly. Then -3 plus 1 is going to give us -2. So we get x minus 3, x plus 1. Again, if you wrote it x plus 1, x minus 3, the order of the parentheses is not going to matter at all. All right. For B, this one's a little bit different. You can go about it different ways. In P3, you saw that there's an formula for this. When it's a square, you can also just FOIL it. You're going to have to distribute different things. You can't take out the 5a plus 1 because the 3 doesn't have one. So you're just stuck simplifying it as much as you can. I'm going to go ahead and FOIL it. So I'm going to do 5a plus 1. In the completed notes that I'm going to leave open, I'm using the formula. You guys are going to have both of them. So when I FOIL it, I'm going to get 25a squared plus 5a plus 5a plus 1. So it's going to be 25a squared plus 10a plus 1. Now I'm going to go ahead and distribute this. I'm going to change the color of the pencil to blue so you see the difference. So it's going to become negative 10a minus 2. And lastly, we're just going to leave the negative 3 by itself. Now I'm going to combine like terms. I am able to combine the 10a and the negative 10a. I'm also able to combine the 1 with the negative 2 and the negative 3. Because those are constants, I highlighted them in yellow. Not because they're constants, I highlighted them in yellow. I just highlighted all the constants in yellow. And then the a's without any exponents, or just the exponent of 1, I highlighted in green. So I'm going to rewrite 25a squared. Then the 10a and the negative 10a cancel out, so I'm just not going to write it. And then I'm going to be left with negative 4. Because negative 3 minus 2 is negative 5, plus 1 is negative 4. Now, this is a perfect square. You can factor perfect squares. So 25, you can factor perfect squares by taking out the square root. The key is in those perfect squares, this has to be a negative. If it's a positive, don't bother with it. It has to be a negative. 25 is a perfect square, 4 is a perfect square, and a squared is a perfect square. So I can go ahead and just do 5a minus 2 and 5a plus 2. And this will be your answer. So sometimes, like we have right here, you have to expand the problem and combine it as much as you can in order to simplify it at the very end. So you have special factoring formulas. Some special algebraic expressions can be factored using the following formulas. The first 3 are simply special product formulas written backwards. So if you know the difference of square, a squared minus b squared, kind of what we just did, it separates into a plus b and a minus b. That is the difference of square. Now you have, the next one you have is perfect squares. It's when a squared plus 2 times ab plus b squared. You can separate it into a plus b squared. That is a little more difficult to spot, but it does happen. Then you have 3a squared minus 2ab plus b squared. It's going to be a minus b squared. Again, it's going to be a perfect square. You have 4a squared minus b squared. It's going to separate into, a cubed minus b cubed is going to separate into a minus b. And then a squared plus ab plus b squared. So that's the difference of cubes. And then you have the sum of cubes, which is a cubed plus b cubed equals a plus b. And then a squared minus ab plus b squared. Now, a lot of these, I'm not a huge fan of memorizing. So a lot of these, when I was your age, I would just work them out as I needed to, and that you would get the same answer. But if you guys prefer to memorize the formulas and just plug them in, that is 100% also understandable. I will not be mad if you do whichever. Just make sure you show your work whichever path you prefer. Now, A and B, I rewrote A in the next slide, and I did not work out B, so we're going to keep it consistent with the completed notes. So we're going to skip B, and if you go to the next slide, we have A rewritten, and then we made up 3 more problems for you guys to solve. Now, here we have, for the first one, 2 perfect squares. Separated by subtraction. Separated by subtractions. I'm going to write sub for subtraction. This actually is the case for all 4 of these. This is something you will see on your test, most likely. So when I do this, all you have to really do is take out that root on both sides. Keep in mind how I'm not including the negative. The subtraction just means that being subtracted from each other, but I'm not taking the negative into the root because that would be imaginary numbers, and right now we're working with perfect roots, so that's not going to get involved. Now 2x squared, the root is 2x, then the root of 25 is 5, so it's going to be plus 5 and 2x minus 5. The same thing happens here. When I take the root of y squared and 100, I'm going to get y plus 10 and then y minus 10. If I call a variable x, just kind of ignore it. I'm going based on the variable that we have, unless it's like there's more than one variable in the equation. For 3, again, we have 9x squared, which is a perfect root, 81y squared, which is a perfect root. So we have, the first thing actually you can do, if you prefer, is you can take out a 9. All of these are divisible by 9. So if I take out the greatest common factor, you can do it two ways. If I take out the greatest common factor, I'm going to get 9, then x squared minus 9y squared. So I'm going to get 9 x plus 3y, x minus 3y. Or if you prefer, you can do 3x plus 9y, 3x minus 9y. But at the end of the day, you have to simplify them by taking out a 3 to be the simplest root possible. So when you do that, you're going to end up with the same thing, 3x plus 3y. And then when you take out the 3, x minus 3y. So you're going to get the same thing. Whichever path you choose, it's fine. And number 4, 1 is a perfect root, guys. 1 times 1 is 1. So that's great news when you're trying to simplify. So that 49 is going to become 7y plus 1, and then 7y minus 1. I'm going to go ahead and mark all of the answers. I'm going to erase the second way just to kind of be consistent with the notes. So this will be the last 2 examples we do for today's class. So they're asking for the cubes. Notice that 27 is a cube root, x is cubed, and -1 is cubed. So when you have a subtraction in between them, it's going to be a minus b. So the minus would go there. A squared plus ab plus b squared. And this one's always the opposite. If you were to have a positive, it's going to be x plus b. Again, same idea. The positive stays in that parentheses, and then it's going to be a squared minus ab plus b squared. Again, this one flips as well. That's always, it's the same formula. Just you got to know when the sign flips and when it doesn't, and go from there. Now, the first step is you take the cube root of whatever you have. When I take up the cube root of 27x cubed, that is actually 3x. When I take the cube root of 1, that's just 1. So what I can do is going to be, well, since it's minus, we're going to use this one. 3x minus 1. And then I'm going to use brackets just because. It's going to be a squared, so it's going to be 3x times... Let me plug it in properly, and then we'll do the math. 3x plus 3x times 1 plus b squared, but it's just 1, so I'm just going to write 1. So I write 1 squared to write in all the formula. Then you simplify it into 3x minus 1, 9x squared plus 3x plus 1, and then that would be your answer. Now for the plus, I'm just going to do it over here. We do the same idea. We take out the cubes. The cube root of x to the 6 is x squared, and the cube root of 8 is 2. So for learning the formula, I'm going to plug everything in, and then I'm going to work it out as well. If you guys can work it out as you plug it in, you're welcome to do so. Just make sure you don't make a mistake. So now we have x squared squared minus x squared times 2 plus 2 squared, all of that in this bracket. So it's going to be x squared plus 2. X squared is going to be x to the 4th. X squared times 2 is negative 2x squared. And 2 squared is positive 4. So this would be your final answer. All right, to keep going, we're going to go over the second part of this page. A trinomial is a perfect square if it is of the form a squared plus 2ab plus b squared, or of a squared minus 2ab plus b squared. You'll notice the entire difference between one or the other is this one positive and negative sign. So we recognize a perfect square if the middle term 2ab or negative 2ab is plus or minus twice the product of the square root of the other two numbers. So how do we check if this is a perfect trinomial? You guys, if you forget the formula, you can factor this like you usually would. Just keep in mind that you're going to get the same parentheses at the end, so you're going to have to write it in the form we're going to do it. Now I'm going to go over how to do it with the formula first, so you guys know it as well. So the first step would be to check if you can take the square root of a and c. If you can, so if yes, you're going to take the square root of a and c. So the square root of a is going to equal a, and the square root of c is going to equal c. If you can do that, then you move on to the next step. You're going to plug it into the equation 2 times a times c. Now, if that equals your b term, you're going to use the formula a plus c squared. If you use the negative, so if it's negative 2ac, you use, again, it has to equal the b term, then you use a minus c squared. Now, how do we know if we use a plus c or a minus c? It's not based on if the answer is negative, if the answer is positive. It's based on solely the two the positive and negative sign that I highlighted in the formula. So if this one is positive, we would use this one. If this one is negative, we would use this one. That is the whole difference of how you're going to choose which one you're going to plug it into. So for this first one, we're going to take the square root of a and c. So the square root of x squared and the square root of 9. So the square root of x squared is x and the square root of 9 is 3. Awesome. Now, I was able to take the square root and I follow the next step. I'm going to plug it into 2 times a, which is x, times c, which is 3. So I'm going to get 6x. Notice how 6x matches 6x. So because we get the same term, we know this is a perfect trinomial. So we go ahead and use the a plus c squared as we have a positive. So it's going to be x plus 3 squared. And then that would be your answer. So for b, when you take the square root of 4x squared and the square root of y, we're going to get 2x for our a, and we're going to get y for our c. Now, after I'm able to take the square roots, I'll check if it's a perfect trinomial by plugging it into the 2 times a times c. So it's going to be 2 times a times c. So 2 times 2x times y for our c. This is going to become 4xy. Now, because this 4xy matches our b, 4xy, we're going to plug it into the a, either plus or minus c. It's going to be 2x, either plus or minus c, y squared. Now, we choose the plus or minus based on this sign. Because that one is negative, we'll just put a negative in the middle, making that give you the final answer. Factoring expressions completely. So when we factor an expression, the results can sometimes be factored further. So in general, we first factor out common factors, then inspect the results to see whether it can be factored by any of the other methods of this section. We repeat this process until we have factored an expression completely. Now I'm going to do examples in the next slide, so just bear with me. So I'm going to write down the steps before we start factoring. The first step would be to first try and factor out any greatest common factor. If it has two terms, for example, is it a perfect square? Can you take, so for number 2, can you take root A and root C, and are they separated by subtraction? If yes, you would use the difference of square. Now, does it have 3 terms? This is kind of how you would, this is just kind of a rule if you have a hard time factoring what to follow. Does it have 3 terms? So, is A 1 or is A greater than 1? So we're going to follow, is A 1 or is A greater than 1? Based on that, you would have to either factor out the trinomial or multiply the whatever the factor of A is times the C in order for you to be able to factor. So make sure that whichever way it is, you factor C. Remember, if it's greater than 1, you're going to multiply A times C to get those factors, and they have to add up to B. Does it have 4 terms? We haven't done stuff with 4 terms yet, which will be grouping. So, if it has 4 terms, can you group first 2 terms? And last 2 terms? Can I factor out after doing that the greatest common factor? And then put it in front of the parentheses. Now, if you do that, if what's left over in each set of the parentheses then you can keep one and form another set of parentheses. With the 2 terms that would factor out. I know I don't have the best handwriting, so it's at some point you can't read it. Please let me know. I write mostly in cursive for myself, so when I write in print, it's not an excuse. It just sometimes looks sloppy. So just, please, if you can read it, ask. I will gladly tell you what that chicken scratch says. A. So, factoring an expression completely. So to factor an expression completely, for A and B, for example, I'm going to just go ahead and take out the greatest common factor, if I can, and see if I can do the difference of square, just because they are 2 terms and they're both subtraction. So they would work for the difference of term. So I can take out a 2x squared for both of these. Now, since I can take out a 2x squared, this is going to become 2x squared in the front. And then this is going to become x squared and minus 4. Just minus 4, because I can take out x squared. Now, notice how x squared minus 4 is a perfect square either way. So you have to keep going. This becomes 2x squared, x plus 2, x minus 2. This is actually your fully factored out problem. As a tip, I always recommend writing the negative to the farthest right. That way you can just copy what you have and keep going from there. If you flip it, it's not going to make a difference. or in this one at least, it's not going to make a difference. But sometimes when you do perfect square, you have to do it 2 or 3 times because they're kind of quite large. So you have like x to the 8th to the 64th, that simplifies, and then that simplifies, and then that simplifies. I think I chose the right numbers. If I didn't, whoops. 81 works because it'd be 9 and 9 and then 3 and 3. So it keeps simplifying sometimes. So if you put it on the very, very right, the negatives, you can keep going and then you can leave the positives alone. If it's a difference of square with a positive, it's not a difference of squares, so you don't keep going. If it's a negative, keep expanding. So for B, I'm going to take out the greatest common factor here, and then I'll move the problem to the right since I kind of overlapped it with A. So this is going to be, I can take out an x and a y squared. So when I do that, it's going to become xy squared, and inside is going to become x4, and then minus y to the 4. Again, this is a perfect square. So this is going to become xy squared, x squared plus y squared, x squared minus y squared. And I can keep going one more time. This is why I mentioned if you put it on the right, you kind of just keep adding to it instead of just having to expand in the middle and then you miss the term that you need to copy. So then this becomes xy squared, x squared plus y squared, x plus y, x minus y. And that actually is your final answer. In the notes, I have them in a different order, but it is the same answer. In the notes, I have them as xy squared, x minus y, x plus y, x squared plus y squared. The parentheses are just out of order. So I'm going to take out a 2 for the greatest common factor, just to kind of make it easier later. So it's going to become 2x squared minus 9x plus 20. If you want to do the factors of 80 that add up to negative 18, by all means, you can go ahead and do that. I'd rather find the factors of 20 that add up to negative 9. So, factors of 20. 1 and 20, 2 and 10, 4 and 5. Now, 4 and 5 work. If I do negative 4 and negative 5, they add up to negative 9. And if I multiply negative 4 times negative 5, I get positive 20. So, perfect. I'm going to do 2, x minus 4, x minus 5, and that is your final answer. Now, for number 2, I have 2y cubed plus 3y squared minus y. The first thing I would do here would be to take out a y. So I can take out a y from all of these terms, so it would become y, and then 2y squared plus 3y minus 5. Now, this is a lot easier to factor. When I get the factors of 10, because again, 5 times 2, it's going to become 1 and 10, 2 and 5, and 2 and 5 can add up to 3 as long as the 5 is positive and the 2 is negative. And again, that works out perfectly because we want the factors of negative 10 as negative 5 times 2 is negative 10. We get y, 2y minus 2, and then 2y plus 5. Now I can simplify that parenthesis 2y minus 2 by dividing by 2. So I get y minus 1, 2y plus 5. It is important that you guys simplify that parenthesis. Now, the reason we don't divide everything else by 2 is because we're treating that parenthesis as its own thing, just because we're factoring it out. It's not going to change anything. It's still going to give us the same answer. But you must simplify those factors as much as you can. So in the next example, we factor out variables with fractional exponents. This type of fractions occurs in calculus. You're not going to see a ton of them. But once you take those greatest common factors out, you'll be fine. If you get this on your test, it would be stuff either from the notes or from the homework. So it will never be problems that you haven't seen before. Again, for these, you want to factor out completely. Again, you start by the greatest common factor. The greatest common factor here is going to be a 3, an x, and a half. The reason I chose a half is because 3 halves is bigger than a half, and all the other terms have a half. So when I go from there, I can take out a 3x and a half. So this is going to become 3x squared. This is going to become minus 3x. And this is going to become plus 2. So we're going to factor this out. Sorry, I forgot to take this 3 out. They cancel out. So it's 3x and a half, and then inside x squared minus 3x plus 2. It's going to be 3x and a half. So it's going to be x. Now the factors of 2 are only 2 and 1. These are the only factors that can possibly exist for 2. So it's going to be 2 and 1. We want them to equal to positive 2 and negative 3, so they're just both going to be negative. Two negative numbers add up, multiply to positive, and two negative numbers, negative 2 and negative 1, add up to negative 3. So that will be your final answer for that one. Now I'm going to go ahead and do B as well. So I'm going to take out a 2 plus x negative 2 over 3. Now I'm going to take it out as 2 plus x negative 2 over 3. And then inside it's going to be x plus 2 plus x. Now I'm going to simplify this to become 2 plus x to the negative 2/3. X plus 2 plus x. So it's 2 plus x negative 2/3. And that's going to become 2x plus 2. I can simplify by taking out a 2. Since we're not factoring, we're just simplifying. I'm going to take that greatest common factor completely out. So 2 plus x to a negative 2 over 3. And it's just x plus 1. Now this problem, guys, you most likely won't see. Now for the next step, we're finally getting to grouping. So, polynomials with at least 4 terms can sometimes be factored by grouping terms. The following example illustrates the idea. So, grouping, you grab the first 2 terms, you grab the last 2 terms, group them together. You factor out the greatest common factor. That's in the previous long paragraph vertical thing that we read at the very beginning of the slide over 12 minutes ago. 2, you factor out each greatest common factor, that's what I just said. And 3, if what's left over is the same inside of the parentheses, then you keep and form another set of parentheses with the 2 terms that were factored out. What does that mean? First step, we separate the first 2 terms from the last 2 terms. Awesome. Now I'm going to take out the greatest common factor from this first one, which is x squared. And I'm going to take out the greatest common factor from the second, which happens to be 4. So this becomes x squared and x plus 1 plus 4, x plus 1. Notice how this is the second step, or the third step. If what's left over is the same, aka x plus 1, you're able to make 2 new parentheses. The first one being x squared plus 4, and the second one being x plus 1 in a multiplication form. This would be your final answer. Now, you don't have to keep going and simplifying because we have an x squared plus 4. If it would have been a minus 4, then you have to separate it into x plus 1, x minus 2. Sorry, x plus 2, x minus 2. For the time being, you can leave it like that as it is a positive. Now, for B, we do the exact same thing. I'm going to grab in there the negative. So when I take out the x squared here, I'm going to get x squared x minus 2. Now notice how in that first parenthesis we have a positive x. So that means I'm going to take out a negative 3 to try and match it. So it's going to be x minus 2. Miraculously, they match. So I can go ahead and do x squared minus 3. And then x minus 2. And that would be your final answer. I forgot to write taking out a negative 2 here, a negative 3 here. I'm just going to write in. All right, guys, last 4 problems. Actually, all of these 4 problems are all factors. Let's do the first one first. We're going to do the first one first. We're going to, I keep clicking, sorry, I keep clipping highlighter instead of pencil. I'm going to separate these 2. I can take out a 3x squared from both of these. So this is going to become 4x minus 3. And then I can take out, trying to be a positive 4x. I'm going to take out a negative 1. So 4x plus 3. Now, this one, you can't combine or do anything else to it. How do you know? You have a negative and you have a positive. It is the exact same information in the middle, 4x and 3. One positive, one negative. So you just end up writing prime because this is a prime factor. So this would be your final answer, prime. Again, we're going to factor this out into... So to factor this out, for the first one, I can take out an x squared. So it's going to become 2x plus 5. And then for the other one, I can take out a 3. So that's a 6, yeah. So it's going to be plus 3, 2x plus 5. They match the 2x plus 5 on both of them, so I'm left with x squared plus 3 and 2x plus 5. So for number 3, again, separate them. I can take out a y squared. I'll get y minus 1. And I can take out a 2. So y minus 1. They happen to be the same. It's going to be y squared plus 2, y minus 1. And then last but not least, we have this problem. So we can take out a 5y squared. We get y minus 2. And I can take out a 3 to get y minus 2. Therefore giving me 5y squared plus 3. And then y minus 2. Remember, you guys have homework on Canvas, but this is it for today's notes.